Types of discontinuities. In the previous video, we have dealt to determine whether or not a function is continuous at a certain point. Now we will discuss different types of discontinuities and how to classify them. By the way, if you like this video, don't forget to like and subscribe to this channel and activate the bell. It is very important for the continuity of this channel. Basically, there are three types of discontinuities you have to know. A jump discontinuity is a non-infinite discontinuity for which the left and right-hand limits are not equal. In other words, the function jumps from one value to another. An infinite discontinuity occurs when the curve has a vertical asymptote. In short, the function goes off to infinity. A removable discontinuity is a discontinuity for which there is a hole in the graph. These three discontinuities are formally defined as follows. If f is discontinuous at c, then f has a removable discontinuity at c if the limit of f as x approaches c exists, but this limit is different of f of c. Let's see how it works. Find the x values at which f of x is not continuous. Then classify the discontinuity as removable, jump, or infinite. To classify the discontinuity of this function, we evaluate the limit of f as x approaches 3. We see that the limit exists and it is equal to 7. We now find the value of f at x equals 3. F of 3 is 2, since the function and limit both exist at x equals 3, but the two are not equal. We say f has a removable discontinuity at x equals 3. Let's see another example. We can see that the function is not defined at -3, but we can evaluate the limit as x approaches -3 by factoring the numerator. After cancelling the common factor, we obtain the limit. We now remove this discontinuity at -3 simply by redefining the function. We can make the function a piecewise function and define a part of the function at the point where the hole is. We can redefine f of -3 to be -2, for example. Let's define jump discontinuity. If it has a jump discontinuity at c, if the limit of f as x approaches c for values of f greater than c exists, and the limit of f as x approaches c for values of x less than c exists, but the values of both the limits are not equal. To do item c, first we rewrite the function. Then we evaluate the limit from the right and the limit from the left. The limit of f as x approaches 2 for values of x greater than 2 is 1. And the limit of f as x approaches 2 for values of x less than 2 is -1. This function has a jump discontinuity at x equals 2. Let's define infinite discontinuity. F has an infinite discontinuity at c if the limit of f as x approaches c for values of x greater than c is infinity, or the limit of f as x approaches c for values of x less than c is infinity. That is, f increases or decreases without bound as x approaches c. To do item D, we can see that the direct substitution fails. So we factor the denominator and the numerator to cancel the common factor. Then we evaluate the limit from the right and the limit from the left. The limit of f as x approaches 2 for values of x greater than 2 is infinity. And the limit of f as x approaches 2 for values of x less than 2 is minus infinity. This function has an infinite discontinuity at x equals 2.